All right, let's go through a real simple example of what happens when we have phase distortion. Phase distortion can be a little hard to picture, but I think maybe this example will help. Phase distortion is a very serious kind of thing, so we can't ignore it. What I'm going to talk about is a technique for sending ones and zeros using radio. Very common technique called frequency shift keying (FSK). So what we're going to do is encode a radio wave or it could be any kind of electrical signal. Um, if we want to send 0, we'll send a low frequency sinusoid. And if I want to send a 1, I'll send a high frequency sinusoid. So the stream 1010 would be a low frequency, a high frequency, and a low frequency. Okay, and we can expand this to send millions and millions of bits. But using this very regular technique, it's easy for a receiver to then decide when it sees a low frequency or high frequency to convert that into a 1 or a 0. We're going to assume these packets, these bits, are L samples wide. So again, this is for us, we're using discrete time, so we actually have discrete samples here instead of a continuous thing. So most receivers have some kind of a filter at the front end meant to get rid of noise, some kind of broadband noise. And let's suppose it's a low pass filter with constant gain, so it has no gain distortion, but its phase is given by this line here. Well, as you know from our previous discussion, this is nonlinear phase. I show the zero, the frequency for 0 bits is being right here on the frequency axis, and 1 bits have a frequency omega 1 it's a higher frequency than the 0 bits. So there's the phase response of the system, and here's the group delay. As you remember, group delay is just minus the slope. The slope here is minus 10, so the group delay is 10 samples. The slope here is minus 1, so the group delay is 1 sample. Okay, so whenever we send a 0 bit, it will get a delay of 10 samples, and whenever we send a 1 bit, it will get a delay of 1 sample. Okay, so what happens when we send 010101 through this system? Okay, we won't get any gain distortion, but here's what will happen. Here's the input, and I've kind of highlighted the zeros in red. The zeros, remember, get the most delay. So this 0 gets a delay of 10, and it gets moved to the right. So it gets shifted to the right. This 0 gets shifted to the right, and it winds up there. This 0 gets shifted to the right, and it shows up there. I'm just going to draw boxes instead of trying to duplicate that sinusoidal behavior. The 1s only get a delay of 1, so I've kind of highlighted them in green. They don't delay much. So there's the first one. It gets moved there. The second one gets moved there. There's a slight delay, which is kind of hard to see on my drawing, etc. So you get the idea. And you could see the bad stuff that's happening. Once it goes through the system, these bits are going to collide. We call this intersymbol interference, when one symbol or one bit lands on top of another bit. And you can imagine that in this region of overlap here, we get the addition of these two sine waves, and it's going to be very hard for the receiver to figure out what's going on. We only have a very small region where it's unambiguous whether a 1 or 0 is sent. And then, in between here, there's no signal at all, so the only thing we get is just noise in between here. And here we got another region of this serious intersymbol interference overlap that's going to totally drive the receiver nuts. Well, this is severe. This is a really bad problem, especially if you're trying to send 1s and 0s fast. You have a high bandwidth, so the high bit rate. So these pulses are very, very close together. It doesn't take much much of a difference in delay to cause there to be some serious overlap. Modern communication systems demand linear phase filters in the receivers. In audio applications, not so much. If you have a audio tuner, an amplifier, and there's some phase distortion, our ears don't really hear that very well. Some people, audiophiles, will claim they can hear phase distortion. My claim is you can't hear it very much, but then, you know, I'm not an audiophile either. So, all right, that's phase distortion. It's a serious thing, so make sure that you have a good feel for it.